All right. Our job here, what we're going to do right now is we're going to graph this dude. Now, to graph this dude, we could do a table of values. We can just pick a bunch of X numbers and plug them in to try to get an idea what this graph looks like. But there are some things that we can use instead of an XY chart to help predict what this graph is going to look like. Like one thing that you guys have already been doing before is find the zeros of a polynomial function. And in order to do that, what you do is you set f of x equal to 0. So you have 0 equals negative 2x to the fourth plus 2x squared. And then you factor and solve. You can factor just as long as it's factorable. We're going to use the zero property to find our zeros. So here we go. Remember that you always want to check for your greatest common factor first. And so I take out a negative 2x to the second power right there. And I get x squared. And the way I got that, I divided this by x, or negative 2x squared. Negative 2 divided by negative 2 is 1. But I don't need to write 1 if I have a variable. And then x to the fourth divided by x squared, you subtract the exponents to get a 2. So you have x to the second power. And then I would take this one divided by negative 2x squared. Now these two are almost identical except they're opposites. One's positive, one's negative. So that means you're going to get a negative 1 when you divide those two. Is it completely factored? No, it is not completely factored. And I want this one to be complete, expanded, factored form. And so when I look at this one right here, I go, oh yeah, that's a difference of squares. That's a perfect square and that's a perfect square. And that right there means difference. And so we have to factor the difference of squares. We have negative 2x squared, x plus 1, and then x minus 1. Awesome. Now is this in complete, expanded, factored form? Almost. You see there's an exponent right here, so I can expand that even more. Some of you guys are like, I've never had to do this before. You're right. You never had to do this before. This would be an acceptable answer. But I'm going to do it all the way. So we have negative 2. We have x. We have x plus 1, and x minus 1. Now the zero property says that if you have a bunch of factors multiplying together, one of them, just one of them, has to be a 0. To multiply to all the other factors to make it all 0. And so what you would do is you would take all the factors that have an x in them, and then you would set each of those factors equal to 0. This factor would be x equals 0. Oh, that's obvious. That one's easy. Next one would be x equals 0. Hey, I already did that one. The next one would be x plus 1 equals 0. That would be x equals negative 1. And you would say x minus 1 equals 0, and that would be x equals positive 1. And so, in conclusion, let's kind of sum it up. The zeros are 0, negative 1, and 1. Now, that's great. So we have 3 x-intercepts for this polynomial function. It crosses the x-axis 3 times. We could even graph them now. We have negative 1, 0, and positive 1. Okay, so now we got 3 points on our graph. We have an idea of where it's going to cross the x-axis. And so what is our graph going to look like? Well, I guess we'll talk about multiplicity after this part. Now you guys know something else about the polynomial functions and how to predict how it's going to look. You know something about the leading coefficient. The leading coefficient test. That's what the book calls it. What is the leading coefficient for this one? Is it positive or is it negative? It is negative. I don't really care about the number. I just care if it's positive or negative. Because if it's negative, that means I have to flip it. Flip what? Well, the other thing that we need to know is the degree. What is the degree for this one? It is 4. It's the highest exponent in the polynomial. That's what the degree is. And so the degree for this one is 4, which is even. That's what we care about for the degree. Now, because it's even, I know it's either going to be a u that goes up or a u that goes down. Because it's negative, I know it's this one. This one is when the leading coefficient is positive, it's this one. Okay, but since it's negative, that's the one that we're going to think about. Okay, so what does that mean? That means our end behaviors, which are these arrows right here, are both going down. And so I like to do this on my graph. I like to put like a corner right here and a corner right here, just so I know, okay, that's where the line is going to end on both sides of the graph, on the left side of the graph and the right side of the graph. And so what do? We draw our line. And it's a very rough sketch. It's not exact. We can get exact by picking points and figuring out exactly how high or how low the line goes. But this is what all you need to do. You need to draw a line coming from the bottom and then connect them. But wait, does it go that way? Or does it go... No, it doesn't, can't do that. What about does it bounce there, bounce there, bounce... No? Okay. No, actually, it doesn't do it. I haven't graphed it right once yet. This is where multiplicity comes in. And I'm going to make up some vocabulary terms here that's not academic at all. Okay, you guys ready? When I come up to this, and if I go through it, that's going through it. Okay? If I come up to this and bounce off, that's kissing the line and then going away from it. And I don't know how this came about, but a student came up to me this year and said, "Hey, Mr. Patey, I remembered it because of what you said." And I was joking last year, and so I guess I'm going to use it because it helped them remember. So if we need to kiss it, we bounce off it. You're just kissing and you're going away from it, okay? That's kissing, okay? So why do we need to know about this kissing stuff? Well, this is where the multiplicity part comes in. Okay, you guys see this 0 right here? Okay, the 0 has a multiplicity of 2. Its multiplicity... Oh, I don't know how to spell there. I'm just going to say mult. Multiplicity equals 2. Now, why do I care about that? Because I want to know if it's even. Now, if it's 2, that means, it's not weird if, the 2 were to kiss, right? Because that's not weird if 2 people kiss. Now, why is it 2? Oh, let me tell you why it's 2. You see up here with all our factors? From how many factors does the 0 come from? It comes from 2 of the factors. These 2 right here. So that means it has a multiplicity of 2. Now what do you think the multiplicity of this -1 is? Yeah, this one. And actually, that's the most common. This has a multiplicity of 1, which is odd. Now, if you have an odd number of people, remember like what I said, that would be weird if the odd number of people were to kiss. And so there's no kissing going on with an odd multiplicity, okay? You just go right through, you walk by, you don't do anything, just go through the points, no kissing, okay? If it's even, kissing's okay. It's not weird, okay? But there's no switching allowed. Okay, next. What is the multiplicity of 1? Now, if you don't understand like the kissing stuff, don't worry about it. Just memorize this. If the multiplicity is even, it bounces off the line. If the multiplicity is odd, it goes through the line. And those of you guys who like the kissing analogy, if the multiplicity is even, it bounces off the line. It kisses the line and goes away. It kisses the line. And if it's odd, you just walk right by it. Okay, you just go through the line and no kissing. Okay. We know that we have to bounce off the 0 exponent. Now, you could circle it, put a B there, whatever is going to help you remember it, or you can just remember it in your head that we're going to bounce off the middle one. All the other x-intercepts, we're going through. And so we start on the lower left-hand side, we go through. How high do we go? It's just an estimation. We bounce off the 0, we kiss the 0. And then we go back down, we go through the 1. And that's an approximate rough sketch of this graph. And if you guys want to, you graph it on your graphing utility, and that should be what our graph looks like. That's the general shape of it. Most wonder how high to go with these arcs, like how do you know when to turn around? And my answer to them is, if you want to know, you pick an x value, like 1/2, you plug it in back to our function to see how high it actually goes. You don't have to do that right now, but you can do that. The other thing is, make sure that when you change directions, like if you're going up, then you start going down, that the line is curvy and not pointy.